All right. So what have we come up with? What are we going to substitute and where?
Substituting 20 feet for D.
Yep. 20 feet. This is going to take the place of D in the formula, so it's going to be 20 equals 6 plus 88t, because here's our speed, so this goes in for V. And then what? Minus 16t squared. Beautiful. No, you're good. My apologies. If you wanted to get fancy with this, how could you possibly write this so that it's in decreasing order?
Negative 16t squared plus 88t plus 6 equals 20.
Yes. If we wanted to solve this, we're not solving this right now, by the way, but if we wanted to solve it, what would I need it to be equal to?
0.
0. So I could also subtract 20 from both sides, and then I would get 0 equals, and I'm going to write this in decreasing order now, negative 16t squared plus 88t, and then what would that constant become? The piece that doesn't have any variables.
Minus 14.
Minus 14. So you could write it either way. So either of those would be absolutely 100% correct. So far, so good? All right. I want you guys to look down at part B and write that equation. Down on part B, I want you to write that equation now. Everybody should have page 83 open. And page 83 out. Where am I going to put the information that they gave us?
Is the 2 gonna go for the 2 gonna go in for T?
Yes. 2 is going to go in the place of T. Yep. 20 is going to go in the place of D. So we would have 20 equals what?
6 plus V
Plus V, parentheses 2, minus 16 times 2 squared. Can I clean that up at all?
Pemdas.
Yep. Yeah, let's use some Pemdas here. Let me write down Pemdas off to the side. Where would we start if we're using Pemdas? Parentheses. Okay, so what do we have to do inside the parentheses? Nothing really, right? So when it says parentheses here, that means like if there's stuff to do inside, we're going to do it. In this case, my parentheses just have a 2 in there. I got nothing to do. So I'm going to move on to exponents. Do we have any of those?
Yes.
Yeah.
What is my exponent?
2.
2. What's being squared? 2. What is 2 squared? 4. What's going on between that 4 and the negative 16 in front of it? They're being multiplied. I want to look at this real quick too. What's happening between the V and the parentheses there? Multiplication, and there's nothing going on inside the parentheses, right? What would be a better or more simple way for me to write this? 2v. Because that still shows me multiplication, right? And when I multiply two things, does the order matter if I do 5 times 7 or 7 times 5? Order doesn't matter when I'm multiplying. Can I simplify this any more than that? I can multiply negative 16 by 4. What do you get when you multiply negative 16 by 4? Negative 64. Okay, so I have 20 equals 6 plus 2v minus 64. Subtract the 20 from both sides?
Oh, well, you would want to combine the 6 and the negative 64.
Let's do that. Let's combine the 6 and the negative 64 together. What do I get when I combine those? I heard negative 50, and then I didn't hear the last number. 58, sorry. My hearing's only so-so. If I ask you guys to repeat it, it's not because you're wrong. It's probably because I just couldn't hear it. What kind of equation are we looking at here now? Is that quadratic? No. How do you know it's not quadratic anymore? Yeah. We don't have any variable that's squared. This is just a linear equation. How would I solve that thing? Yep, I'm going to add 58 to both sides. So I would have 78 equals 2v. V equals 39. So what did we just find? The velocity. Do I need units with my velocity? Feet per second. Look up at the top. It says the speed of v feet per second. I also had a clue that they were using feet and seconds because of that negative 16. Remember when we talked about gravity? So I knew it had to have the feet part anyway. Cool. So we were able to actually solve this one. All right, number 3, we're going to go through number 3 together, and then you guys are going to do number 4, that's on page 84, either on your own or with a partner. Number 4 is astoundingly similar to number 3. So we're going to do number 3 step at a time together, and then you guys are going to get some independent practice time with the same process. And this really gets to one of the big focuses for the test next week, which is a week from tomorrow. We're focused on forms. This entire question with all of its parts is focused on forms. All right, so it says a company's profit in thousands of dollars from an item depends on the price of the item. So far that makes sense. The amount of money that they make off of it is based on how much they charge for it, right?
Thank you.
There are 3 different expressions for the profit at a price of P. I hate that they're talking about profit and price because they both start with P and I'm going to get confused. So you're going to see me do a lot of labeling in here so that I don't get lost. They gave us 3 different expressions. What form is the first one in? They're all quadratic. This is general. This is my general or my standard form. Why do we like general form? Why do we like standard form? What does it tell us just at a glance? The y-intercept. That's what it's good for. What form is the middle one in? Factored form. Also sometimes gets called intercept form. What's it useful for? The roots. And then what about the last one?
Vertex form.
That's our vertex form. And why do we like it? Gives you the vertex. How could you convince someone? I'm thinking of my 5-year-old. She knows very little about algebra, although she's starting to scare me recently. Like, not in a bad way. Like, she had a full-on discussion with me about prime numbers the other day. She started the conversation. Mm-hmm. She also loves this cartoon called Number Blocks, which is honestly pretty cool. It makes learning the way numbers behave interesting and fun. So she can think about how things can be divided by 4 because she sees these blocks and then they split into pieces. And so it makes it much more relatable. Okay, so we want to convince someone that these 3 expressions are equivalent. What does equivalent mean? Equal or the same. So we want to prove that all 3 of these are the same, that they're describing the exact same parabola. Do we know how to go from general form into factored form? Mm-hmm. Can we go the other way? Can you go from factored form into general form? Mm-hmm. Most of the time, yeah. Can we go from general form into vertex form?
No.
Not as easily. We haven't talked about it formally in this class. You guys talked about it and looked at it in Algebra 1 and in Algebra 2, but we haven't reviewed how to do that yet. There is a way. Can we get from vertex form into general form?
Yeah.
That's much more straightforward. Guys, I need everybody's eyes up here on page 83. I realize it's gorgeous outside, and for whatever reason, that means like everyone all day long has been on their phones, like constantly, and I get that outside would be way better than being in here. But if we can stay focused on this, we can get wrapped up hopefully fairly quickly, and then y'all can check out. But stick with me until then, okay? So the way you would convince somebody that these are all the same, we're going to put them all in the same form. Since we know how to get from factored form into standard form, and we know how to get from vertex form into standard form, I vote that we put them both into standard form. And as long as all 3 of them match, we're good. The process itself isn't hard, but there's lots of places for little mistakes. So I want to pay attention to this because I want to walk through these steps and make sure that we're really solid on what we're doing so that if a mistake happens, you guys can go and find it. Okay? Let's start with our factored form. What is our factored form? Yep. -2, and then inside parentheses, p minus 3 and p minus 9. To go into standard form, I'm always using order of operations. What is order of operations again? Pemdas. So parentheses, but again, that's if I can do something inside it. Can I do something inside these parentheses? What about inside these? Do I have any exponents? No. Do I have anything to multiply? Yes. I've got the -2 and what else? Yeah. The two sets of parentheses are being multiplied together as well. I'm going to focus on that first because I feel like that's the place where mistakes can happen the easiest. And then we'll worry about that -2 afterwards. So my attention right now is on these two pieces. We're going to use some double distribution now. Why does it have to be double distribution? Yep. I'm going to take this first term. It has to get distributed to both pieces. But then I also have to take my second term and distribute it to both pieces. So when I take p and distribute it to p, what do I get? P squared. What about p times -9?
Negative 9p.
-9p. So minus 9p. And then we take the 3 and distribute it also, and it's a -3, right? So what do I have next?
Negative 3p.
-3p and a +27. I had these guys like bracketed off from everybody else, right? Because we still have what out in front? -2, and that's also using multiplication, isn't it? So let's distribute that -2 to everybody now. I do my double distribution first, and then I distribute the -2. So what is -2 times p squared?
Negative 2p squared.
-2p squared. What's -2 times -9p?
Positive 18.
+18p. -2 times -3p?
Positive 6p.
+6p. And -2 times +27? -54 is correct. Is there anything else I should do to this?
P and p.
Yes. We're going to add the 18p with the 6p. So I have -2p squared plus what? 24p minus 54. That's the same as our general form, right? Compare it, -2p squared plus 24p minus 54. All right. Same thing, but now with vertex form. What is our vertex form? Order of operations again. Parentheses. So I'm looking inside my parentheses. Can I do anything? What about exponents?
Yeah.
Yes. What does it mean to square something? Multiply it by itself. I'm going to pull that off to the side because I'm going to have to use some double distribution. You do not just square the p and square the 6. You have to double distribute because you're taking p minus 6 and you're multiplying it by itself.
We do the double distribution, right?
So p times p, I get p squared. P times -6,
Negative 6p.
-6p. Yep, and then we have to do -6p and a +36. You are more than welcome to combine your like terms at this point. If you want to wait and combine your like terms in just a little bit, you can do that also. I'm going to hold off on combining those like terms. Oh my goodness. This is giving me fits. Okay, that works. So I still have this -2 out in front. And we got p squared minus 6p minus 6p plus 36. And then on the end, I had a plus 18. The -2 is only being multiplied to those parentheses, right? So I'm only going to distribute it to the stuff that I got after I did my double distribution. I am not distributing it to the 18. So take that -2, distribute it all the way out here. So I have -2 p squared,
Positive 12p.
positive 12p, negative 72, and then don't forget to bring down that plus 18. Now I'm going to combine my like terms because now I'm at the addition and subtraction step. What like terms do I have to combine?
12p.
Yep, 12p, 12p, and then negative 72 plus 18. So I have negative 2p squared plus 24p minus 54. Same exact thing. Same as my general form from up above. How are we feeling about that? Pretty reasonable? All right, let's look down at the next couple questions here. Question 2, or question A, sorry. Which form would make the most sense for the break-even prices? What are break-even prices? Any ideas? So a break-even price, I want you to imagine for a moment that I'm working on a project and I'm going to sell what I make at a craft fair. I'm going to knit some stuff. I don't know. I'm making it up now. I need to first go and buy the supplies, right? So I start off with how much money? However much I had to spend to get started. So technically I start off in the negatives, right? Then I go to the craft fair. The first couple items I sell, have I made money? No, I've just been earning back what I spent on my supplies, right? Break even is when I finally paid off all my supplies. Everything after that is profit. That's money that I've actually made. Y'all finished? Absolutely. Okay, so break even prices means that my profit is how much? 0. Profit is 0. We've paid off the supplies. Or if you're in business classes, we could say we've paid off our overhead, because that would include more than just supplies. That's your labor, that's your utilities, your maintenance, all that stuff. Well, does the P in these expressions mean profit?
No.
What does the P in the expression stand for? The price. If it's in the expression for price, is that normally X spot or Y spot? X spot. So price is my X variable. So what's my Y variable then? That's my profit. So their question for me here, when they're saying the break-even prices, that means I'm looking for the price when the profit is 0. What is that? Those are the x-intercepts. Which is the same thing as what? Yep. It's the same thing as my roots. And you answered my second question, which is, what form helps me do that? Factored or intercept form. So, what are those roots? What would the order pairs be? Tell me why you changed yourself there. I like it.
Because in the actual base equation, it already has the subtraction. So if it's positive, it should subtract.
We take our factors and we set them equal to 0, and then we solve them for p. That's why the base equation has that subtraction in there. So I get that p is 3. For the other one, p minus 9 equals 0. So I'd add 9 to both sides. And p is 9. So that's where the 3 and the 9 came from. So the break-even prices are $3 and $9. Any idea why there's 2 break-even prices? If you don't charge very much for your item, are you going to make very much money? It's going to take a lot longer to earn back the money that you spent on your supplies and your overhead. If you charge a lot of money for your item, do very many people want to buy it? No. So fewer people buy it, which means you end up not making a lot of money because you didn't sell very many of them. Does that make sense? All right, let's look at question B. What form would I use to find when the profit when the price is 0? Which one? General form. Also called standard form. Why? Why is that the form that we want? Because that's when the price is set to 0. So I'm going to grab this ordered pair and move it over there. So if the price is 0, and then we have the profit over here, that's a y-intercept, right? And general form or standard form is what tells me my y-intercepts. So what is the profit when the price is 0?
54.
Yep. 0, comma, negative 54. That's my C value. That's where we're getting this from. So what does that mean?
If the price is 0, they're making a profit of -54.
Yeah. The profit is negative 54. Just $54? Look at the beginning of the problem.
Oh, God.
Yeah, negative $54,000 when the price is 0.
So that would be like the money that they spent on supply, they have to give it back.
So their overhead is $54,000. Obviously, they have a large company. They've got a lot of employees. They've got a lot of things they have to pay for, office supplies and whatnot. Yes, sir. All right, last one, and then you guys are going to get turned loose on number 4. Process of elimination should tell you which form we're after this time, right? Vertex form. What do they want to know?
The maximum, which is the vertex.
Yep. The maximum, which is the vertex, and the price that goes with it. So we're going to look at vertex form. So what is the vertex of this? 618. What does the 6 represent? That's our price. What does the 18 represent? The profit. So take this ordered pair and help change it into words for me. When will they receive their maximum profit? Yes. When the price is $6. So I don't know what this item is, but $6 is obviously, that's the sweet spot. When the price is $6, the max profit of $18,000, because remember they're doing that in thousands, is reached. All right, you guys have 10 minutes now to work on number 4. You're welcome to work alone if you want to. You're welcome to work with a partner if you want to. But I want you to answer, I think there's 5 questions there because part C is broken into 3 parts. Also, it's a little bit confusing, or at least I thought it was confusing. On part C, do you see how there's those lines to write on? But it says which form should you use for each of the questions below. Skip those lines for part C and just answer the 3 questions that are under part C. Okay? We'll talk about these answers in about 8 minutes, 7-8 minutes. So I want to briefly recap this in the last 2 minutes before the bell. Why are there 3 forms? Why didn't she just write down 1 and be done with it?
Where the starting height is, where the maximum height is, and how far the range is.
Close.
When he hits the water.
When he hits the water. These 3 forms each highlight, at a glance, without having to do any algebra, different pieces of key information. So having it in the 3 forms makes my work easier. Could you convince others that all 3 of these rules are mathematically equivalent? Yes. Put them all into the same form. If you didn't do that already, that's where your practice needs to be. Because I guarantee you, I will ask a question, are these parabolas the same? And they're not going to look the same. Which rule would you use for the maximum height? Vertex form. When is that?
We'll be at
64?
64
And 1. So at 1, I'm assuming this is second. At 1 second, the max height of 64 feet. What form would you use to figure out when he's going to splash into the river? Factored form, because it'd be doing this, right? What are the x-intercepts?
-1, 0, positive 3, 0.
So when does he hit the water?
At 3 seconds.
At 3 seconds. How high was the cliff that he jumped off of? 48 feet. What form did you look at? General form. All right. Guys, there's no new homework other than that review between now and the test. If you're missing any homework, this is a great opportunity to make that up and get those scores in. Have a great rest of your day, guys. I'll see you tomorrow.
We don't never use that. I just get up there and throw it.